Okay, in this video I'm going to go through and show you how to do solving exponentials. So when we have our exponentials, we want to change what we've got on the other side to the same base as what we've got here. So we've got 3 to the power of x. I want to write 27 as 3 to the power of something. So this is where it comes in handy knowing your powers of primes. So we know that 3 to the power of 3 is going to give me 27. So instead of writing 27, I can write 3 to the power of 3. And then that means when I've got 3 to the power of x is equal to 3 to the power of 3, I know that then x must be equal to 3. So that's the relationship that I can see there. The next one we've got is a little bit different because we've got the negative. Now, same deal here. I've got 1 over 64. I've got a 4 here, so I could change it to a 2, but because I'm looking at my 64 and I know that 4 to the power of 3 gives me 64, I'm going to leave it in the power of 4. So I've got 1 on 4 to the power of 3 is going to give me 4 to the negative x. Now, using my index laws for negative indices, I know that I can write my 4 to the negative x as 1 on 4 to the x, and I've got 1 on 4 to the power of 3, therefore my x must be equal to 3 here. The other option is to bring that one up here and write 1 over 4 to the 3 is the same as 4 to the negative 3, and then write that the negative x must be equal to negative 3, therefore x is equal to 3. So a couple of little options there. The next one a little bit trickier because I've got a 25 and I've got a 5, so I want to change that first. So my 5 to the n stays the same. I want to change my 25 to 5 squared. And my 125 I want to write as something 5 to the power of something. So I know that that is 5 to the power of 3. So I'm going to change that straight away. Now I'm going to expand out that bracket using my index laws. So I've got 5 to the n times. Now when I expand that out, I will get 2 times 2n is 4n, and 2 times negative 1 is minus 2 there. Now, using my other index laws, I know that if I'm multiplying with the same base, I can add the powers. So I've got 5 to the power of n plus 4n take 2. And then when I've got my n plus 4n, I know that's going to be 5n take 2 is to the power of 3. So then I can write to the side here, therefore, my 5n take 2 must be equal to 3. And I can solve that. So I can add 2 to both sides and get 5n equals 5, then I can know that n must be equal to 1. I can then go back and check that if I want in the original equation and type that in and check that it worked. The last one I've got here is 3 to the power of 2n minus 4 equals 1. Now I've put a little note over here. Remember that anything to the power of 0 is equal to 1. So if I've got a 1 there, I can immediately write 3 to the 2n take 4 is equal to 3 to the 0. So I can write it in the base 3. Because I've got a 1 there. So I know 3 to the power of 0 is going to be equal 1. That means I can put it in the base that I want. Now I can do that relationship here that the 2n minus 4 must equal 0. And then I can solve for n. So I can add 4 to both sides. 2n equals 4. And then divide by 2 and get n is equal to 2. Hope that was helpful with your solving exponentials. We do have another example where we use our calculator. So we've got 2 to the power of x equals 5. Now, obviously when we get into logs, we're going to show you how to solve that way. But what we can do is similar to my previous video where we graph the exponentials, is put in our 2 to the power of x, which we already had from last time, and instead have y equals 5, and we can see where those two cross. So my graph is coming up there, and then my 5 is going to come across, and then I'm going to use that same process that we used in the first video, which was second trace and our 5 for intersect, and just press enter, 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 and we get an intersect at 2.321 for our x. Now when we get into logs, obviously we could do the log of both sides, then bring the x down, and then divide log 5 by log 2 and get our answer, but we'll get into our log laws in the next video. Now the last little one here, we've got an inequality. We can still do it the same way. So I know that 49 is 7 squared, so I've got 7 to the power of x is greater than 7 to the power of 2. I can then write x is greater than 2. So we can still do it the same way. We just have to keep that inequality sign there. Hopefully that helps, and in the next video we're going to get onto some logs.